So, very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the class 7 students. Class 7 students for today's session. As you can see on the screen, and you are well aware, my subject is physics. We are in class 7th. Our ongoing chapter, that is chapter number 3, laws of motion. Today we are entering into the second session, second class. So in last class itself, we started the third chapter, Newton's laws of motion. Right? So before going for today, that is, we'll continue where we stop in the last class. But before that, let us recall what we learned in the last class. So in last class, we learned about, before entering into the Newton's laws, we discussed about what is the need of Newton's laws. Why Newton's laws are proposed by Sir Isaac Newton. He is a Newton. Why he proposed means when he is studying about the motion of body over anxiety, he want to know what is the cause of motion, what is the reason for motion of a body. With that excitement, with that anxiety, he introduced the word called force. The word force is introduced by Sir Isaac Newton. The study of force, when they started studying about the forces, after studying entire thing about the forces, types of forces, effects of forces, he proposed the 3 important laws on force, or which are popularly known as Newton's laws of motion. So in last class, we discussed about the entire thing about the force, what is force and all. And now today, we are going to discuss about we enter into the Newton's laws first. Right. So we enter to the Newton's laws. So just recalling this, we discussed about what is forces, what are the types of forces, what are the effect of forces and all we discussed in the last class. Right? A force is either push or pull on a body, which can change or try to change the position of a body. So force can change a body from rest to motion also. A force can bring moving body to rest. Force can change the direction. Force can increase the speed or decrease the speed. Force can change the shape of the body. Force can change the size of the body. All these comes under effects of forces. We can see these all in our day-to-day life. Then all these forces, there are so many forces are there, like magnetic force, electric force, frictional force, applied force, spring force, tension force. All these forces are classified into either contact forces or non-contact forces, balanced forces, unbalanced forces, which you already learned in the earlier class. So all these, so many examples we discussed about the force. Now we enter the actual chapter, that is Newton's laws. In that, today we will discuss about the Newton's first law of motion. So what Newton's first law said? A body continue to be in the state of rest or uniform motion along straight line unless or until is acted upon by some external force. Simple logic you can find everywhere. Suppose you kept your bag on table while going home, and tomorrow morning you come to school, your bag is there only, same place. Why? Because there is no external force acted on it. So until unless external force is acting, body maybe continues to be in the state of rest or in motion. Okay. So if no net force acts on a body, then velocity of the body cannot change. That is, the body cannot accelerate. Newton's first law defines inertia and rightly called as law of inertia. So why body is not changing itself? Because that is the internal property of the body, inherent property of the body. No body can change its position itself until force is applied. The body may be at rest or body may be in motion, right? That's such property, internal property of the body is called inertia. A new word came from Newton's first law. That's why Newton's first law is also called as law of inertia. Okay. See here, they clearly explained. From Newton's first law of motion, it can be safely concluded that a body will change its state of rest or uniform motion only if some external force acts on it. In other words, anything or material is incapable of changing its state of rest or material is capable of changing its state of rest or uniform motion. Hence, is a state of inertness of the inertia. No body can change its state of rest to motion or motion to rest unless an external force is applied. Such a property, such an inherent property of a body is called inertia. Right? So, okay, definition is given exactly. The tendency of a body to continue in the state of rest or uniform motion in a straight line, even when some external force acts on it, is called inertia. Right? So inertia is of three types. You can find inertia of rest, inertia of motion, inertia of direction. For example, all three I would explain one single example. Suppose you are sitting in a bus. In bus stop, bus came and stopped. You sat in a bus. Right? So bus driver came, entered the bus and started the bus suddenly. Suddenly started. So what happened? You will feel jerk, back jerk. Why? Because you are sitting in the bus rest. To make your body to come from rest to motion, you need to apply some force. But as he started suddenly, we don't know that happen. Bus is starting, so we feel jerk backward direction. Same time, bus is going with a great speed. Suddenly, one vehicle came or speed breaker came. So driver applies the brakes. So you can see will fall for front. Sometimes will be hurt also. Why? Because as we are moving along with the bus, our body is not able to come to rest suddenly because there is no external forces applied. That is the reason seat belts will be provided to avoid such an accidents. Right? Similarly, when bus is taking turn, sudden turn, we cannot sit straight like this. We have to bend in a direction where bus is turning. Why? Because our body is not supporting to change its direction itself. Got it? Understand or not? So, not only our body, any body. Tendency of the body, it cannot change its state of rest or motion in a straight line until and unless an external force is applied. And that tendency of the body is called as inertia. Hence, the Newton's first law of motion is also called as inertia. See, there are some examples for inertia of rest. So imagine a pile of books one over the other. Pile of books placed on a sheet of paper. Take one sheet of paper, place some books one over the other. Okay. And if the paper is pulled with jerk, the books are left behind because of the inertia of rest. Very interesting. Same thing you can do the glass also. Suppose one glass you take, place one paper on that, put some coin at the center here, coin, and you pull the paper. When you pull the paper, coin won't come with the paper. Coin will fall into the glass because inertia of rest. It cannot move because we are not applying force on a coin, or we are not applying the force on a paper. That is books. Place one paper on books, paper on table, place some books one over the other, 2-3 sets. Pull the paper. When you pull the paper, books remains there only, they won't move. Why? Because of inertia. Inertia of rest. As they are at rest, they cannot change the position until force is applied on them. Second one is see. Just now I told. A passenger sitting in a bus falls backward. Second, falls backwards when bus suddenly starts. The reason is that when the bus moves, the passenger, due to property of inertia of rest, are left behind and hence fall backward. When a carpet is suddenly jerked, carpet will then at home go and jerk it. So much dust will come out. Right. Dust flies off because of the sudden movement. The carpet moves, but dust on the accounts of inertia of rest is left behind. When the branches of tree laden with the fruits and shaken, the tree is there with a lot of fruits. When you shake the tree, what happens? The fruits fall down. The reason is that when branches are more suddenly, the fruits on account of the inertia of rest are left behind and fall down. So many examples are there for the inertia of the rest. Okay. Right? Clearly understood. Okay. That is a one type of the inertia. Next, we move to second type, inertia of motion. Same, I told bus. Bus is moving with a great speed and suddenly stop. Suddenly apply the brakes. So what happens? When the suddenly apply the brakes, we can feel, we'll jerk, we'll fall front. So because our body is in motion along with the bus, when bus suddenly stops, our body not supports because of its tendency. So similarly, there are so many are there. Rider, when you are going by either by horse riding or any riding, when galloping horse stops suddenly, when the horse stops, the rider on account of inertia of motion continue moving and hence falls in the forward direction. A running boy falls forward direction tripped by the stone. When stone is struck, the stone will forward. Why? Because we are running. We cannot come to rest after striking the stone. Then before taking a long jump, very important this is, when you want to take long jump or a javelin throw or discus throw or cricket bowling, why the bowlers are taking some run up? Why can't they bowl directly from the line crease? Because they want to make their body from rest to motion before bowling the ball or before throwing the discus or before throwing the javelin. You can observe every time, long jump, high jump, javelin throw by Neeraj Chopra. All they will run for some distance before. Similarly, bus example, that is comes under inertia of motion. The third one is inertia of direction. Direction. The tendency of the body to maintain its direction of motion known as inertia of direction. A stone tied, right, you can see here, you take one stone and tie to thread or rope, tied to a world, means rotate. The direction of motion of any instant of time is tangential direction. It always goes perpendicular. When knife is sharpened by the placing it on rotating wheel. Sharpening now knives will happen. Na? When the knife is blender, we sharp it with the machine. So the tapering, the fire will come, sparkles will come in a tangential direction because of the inertia of direction. And similarly, when you are turning by either cycle, two-wheeler or four-wheeler, will bend because of the inertia of the direction only. So these all are the examples for the inertia of direction. So it totally makes Newton's first law of motion. So law of inertia, which is popularly known for its law. So before going for the next part, that is second law or some other thing, let us see one video on Newton's first law.
Imagine you're sitting on a recliner chair watching your favorite movie on a lazy Sunday. And your mom calls out your name and asks you to run some errands. You can imagine how difficult it would be for you to get up and do the work. Imagine you're practicing for your 100 meters race on this track. And somebody asks you to stop immediately within a second. Will you be able to do it? What if you're suddenly asked to turn towards the right? Will you be able to turn immediately? The answer to both the questions would be a no. You can stop, yes, but gradually. You can also turn, but not sharply. And guess what? It's the same story with every object. Every object will continue to do what it's doing. If it's at rest, it will remain at rest. And if it's in motion, it will stay in motion. But what can change this? Yes, only an unbalanced force can change this. If it's at rest and an unbalanced force acts on it, it will move. If it's in constant motion and an unbalanced force acts on it, it may accelerate or change direction. And this is nothing but the Newton's first law of motion. Here's the correct definition. An object at rest stays at rest, and an object in motion stays in motion with the same speed and the same direction, unless acted upon by an unbalanced force. In simple words, it means that the objects continue to do what they're doing unless some external unbalanced force acts on them. We can also understand this using a simple diagram. If the forces are balanced, there can be two cases. An object may be at rest, or an object will be in motion at a non-zero constant velocity in a particular direction. These can be the only two cases when the forces are balanced. In the first case, the object will continue to remain at rest, and in the second, the object will continue to stay in motion at the same velocity and in the same direction. Don't forget, these two cases will remain true only if the forces are balanced. In the next video, we will look at a few applications of the first law of motion.
Right. So, as long as you apply the force, the body will move, or body will come to rest, or body will change its motion. One more is there video I can see before.
You should already know what we mean by an object has a velocity, and what we mean when we say an object has uniform motion. If not, you may want to check out this video first. In this video, we're going to look at how the velocity of an object depends upon the forces acting on it. In physics, we have three fundamental laws of motion, created by Sir Isaac Newton way back in the 17th century. Today, we are looking at the first law of motion, sometimes called the law of inertia. Newton's first law says that an object will remain at rest or in uniform motion in a straight line unless acted upon by an unbalanced force. But what does this actually mean? Firstly, it means that when an object is not moving, it will remain at rest until an unbalanced force acts on it. The statement also tells us that an object will remain in uniform motion in a straight line unless acted upon by an unbalanced force. Take a look at this ball here. As the child kicks the ball, they exert an unbalanced force on it, changing the ball's velocity and causing it to move. But as it rolls along the ground, the ball will slow down and will eventually come to a stop. Because the ball is slowing down, we can say that its velocity is changing. By Newton's first law, this means that the ball is experiencing an unbalanced force. In this case, it's the force of friction that opposes the motion and eventually stops the ball. Note that there is no forward force on the ball. She is no longer kicking the ball, so there is only backward frictional forces which slow the ball to a stop. Look at the diagram of the aeroplane shown. If the thrust of the engines is equal to the drag force, it will move forward at a constant speed. The plane will travel at constant height if its weight is balanced by the lift force from the wings. We have uniform motion. If the plane wants to move faster and increase its velocity, then the thrust force pushing the plane forward needs to increase. It becomes larger than the force of air resistance and creates an unbalanced net force. The plane now accelerates, no longer moving with uniform motion. Drag increases with velocity, so very soon the plane will have balanced but larger forces again, and its velocity remains constant but higher than before. Quantitatively, we can find the net force of any object by considering the size, or the magnitude, and the direction of each force acting on an object. It can help to draw on the forces yourself. Take a look at this example here, which shows three forces acting on the object. The two vertical forces are equal and opposite, therefore cancelling each other out. However, the horizontal force has no opposition, and so it remains unbalanced. This means that the net force will act to the right and will have the magnitude of the horizontal force. When working out the net force, it's a good idea to consider the horizontal and vertical directions separately. At the end, these directions can be added up to give you a diagonal force. You can think of these forces to be a bit like points on a compass. If we add together north and east, assuming the forces are equal, we will get a result of northeast. Now you try. What direction do you think the resultant force will be here? Pause the video and have a go. The resultant force is obtained by drawing lines parallel to the forces to make a parallelogram or rectangle. Well, first of all, we need to find the resultant horizontal.
So different types of forces acting, based on that, the body will change its direction. What that is, as long as you are applying the unbalanced force on a body, it is at rest or uniform motion, called Newton's first law or law of inertia. So there are three types of inertias: inertia of rest, inertia of motion, and inertia of direction. Okay, that is about the Newton's first law. So before going for the Newton's second law, right, we have to discuss about one important physical quantity called momentum. We know that a cricket ball is much heavier than a tennis ball, right? Suppose we throw a cricket ball and tennis ball both with same velocity, it will found that more force is required to stop cricket ball and less force is required to stop the tennis ball. Correct or not? Cricket ball is heavy mass, tennis ball is light mass. So you are throwing both of them. So what the observation is? So more force is required to throw the cricket ball or stop the cricket ball when compared to the tennis ball. We conclude that the force required to stop moving body is directly proportional to its mass. F is proportional to m. No doubt. Suppose heavy mass body required more force to stop. Less force body required less force to stop. If you throw two cricket balls, both are cricket balls only, same mass at different speed or velocities, it will found that the more force is required to stop the cricket ball, which is moving with the higher velocity, or less force is required to stop the cricket ball moving with the low velocity. So we can conclude that force required to stop a moving body is also directly proportional to velocity. So F also proportional to V. So if you want to stop the ball with more velocity, we require more force. Ball with less velocity required less force. So thus the quantity of motion of a body on mass and velocity of the defined as the product of mass and velocity. Momentum is denoted by P. So the product of mass and velocity is called momentum. That is P is equal to M into V. Correct? Where M is the mass of the body, V is the velocity of the body. So the applied force will create the momentum in a body. So this momentum is responsible for the second law of Newton. That's why Newton's second law is also called as law of momentum. Momentum is nothing but product of mass and velocity. P is equal to M into V. So as you know that the unit M into V, so you can write P is equal to M into V. M is measured in kg, V is measured in meter per second. So unit are kg meter second inverse. Because second by second you can take numerator. Or it's also can write gram centimeter per second also in CGS system. Okay. So the momentum of a body depends on mass and velocity, no doubt. It is a product of mass and velocity, which is the fundamental law of Newton's second, which is completely defined based on this only. Right? So when we meet in the next class, we'll discuss about in depth about the Newton's first law and final by Newton's third law, second and third laws with various examples. Number of examples are given for both. It's second law, first law, and so many important examples which are applicable in our day-to-day life. Okay. So wonderful laws are there by Newton, which are basics for the physics. Physics is mainly comes into light because of these laws only. So in next class, we are going to complete this Newton's second law and third law, by which we complete our chapter number 3 and we'll enter to the chapter number 4. Right? So that's all for today. So today we will learn about we done with the Newton's first law and introduction of Newton's second law. Okay. Proposed by Sir Isaac Newton. So that's all for today. Thank you, students. Have a wonderful day. Thank you.